Okay, recording now. I don't know if you want to go, do you want to go over the instructions first, or did you read the instructions?
Yeah, I did. I just went over it. So, yeah, it would be great if you can go over it again. Last night, right? Late last night before you.
Okay. Right, so the first line is basically a reminder that the layout has to have a set of ports that match the schematic. So, you know, not just any old layout will do, right? And not just with labels, they have to be defined as ports. Otherwise, you don't get a subcircuit when you extract, when you do a post layout extraction, you don't get a subcircuit, or you may not get the, the correct set of ports. We're going to do a batch extraction in Magic, so it can't see what's in memory in a running Magic session. So you have to save, make sure you've saved what you need to out of an interactive Magic session. Change to your project's mag directory. Run the batch RC extraction. So this is going to output a spice netlist for that cell and generate a log file. And technically, you can name these anything you want on the command line, but your Magic to SPI is the basic batch extract command. Give it the name of your cell and store the log somewhere, and then examine those for any wildcard, any unusual errors. There's a lot of stuff in the log that's going to be irrelevant, but so especially in the SPI, it has to have the dot subcircuit for your top cell. So the script itself gives you a warning if there's no dot subcircuit for the top cell. So if this message shows up in the log, that's a red flag that something's wrong. Probably you don't have any ports defined. So verify that does not show in the log. Now, if you're happy with that netlist, you can import it in such a way that it's visible to the RCX switcher that's used by the electric SIM button. Meaning there's a specific place in the directory structure where it's going to be stored, and it has to be stored. So far, this is just in your mag directory, this SPI file. So the RCX import will do that. You give it the name of this spice file you're importing, and then give it the library name and cell name, target library name and cell name. And if every schematic that you work with in electric has a library name and a cell name. So these have to be a match to the schematic that you're replacing. Whichever electric library name and cell name you're replacing, that's what these are for. But the cell name also has to be a match to the subcircuit name in the netlist file, which is your top cell. Okay, so meaning you can't just import a spice file without also saying for what electric lib it's associated with. And we'll look at I'll show you an example of what this directory structure looks like a little later. Then you have to tell SIM corners to use RCX switching. This is basically, so far, this is just an on-off control. Each project already has an EF config directory, and in that config directory, you need to create this view-switch.cfg view-switch.cfg file. This is intended to grow into a real config file in which you can turn RCX switching on and off by cell, with a large degree of freedom and controls. So far today, it's just a single global Boolean for that project. And so if it exists, RCX switching is used as much as possible. If it doesn't, meaning if you delete the file or move it to another name, RCX switching is disabled. So once you've created that file, you can now come back to your electric session and looking at your test bench schematic that places the cell, the electric the symbol for the electric schematic that your layout is corresponds to. You should have a test bench, a separate upper level test bench that incorporates that in its hierarchy and run the simulation button. Now in the terminal of this in that log that pops up when you hit sim, near the top of the file, you should see some lines that state what RCX switching is doing on your behalf. And then, of course, look at your raw file and see what you get. But open it in SimProbe. So here are some specific examples using a real name, using challenge name. So in this case, for the purposes of the challenge, this was the project name and the electric library name and the cell name were all identical to this. So this was the electric library, and this is the schematic, the identifier for the schematic in that library. So assuming you created a layout in your mag directory with the same name, then this would be an example of running the netlisting it, doing an RCX layout extraction, netlisting the layout for Spice, which would output this netlist. So we then import that netlist and we specify the electric library name and the cell name. Again, both of these: target library, target cell. So that's it for the instructions. Let's look at a test case. Here I've got this, I basically took the if examples test INV, and I drew my own schematic for that, which is what we're looking at here. Somewhat simplified from the EF examples version. It's basically a simple inverter. I've got a symbol for it, and I've got my my version of the test INV schematic, in which I've replaced these, to be references to my INV4. Both of these are my INV4. And if I run, let me delete that. Here you can see the output net as a result of simulating that test INV. And then here's my Bob Marley layout. I'm using P cells for the NMOS and the PMOS, and I've just wired them up simply as an inverter. I've got power and ground, input and output defined as ports, and all my port names are a match for the schematic names. In, out, VSS, VDD. So if I go to my mag directory and I run this is the command I'm going to run. And if I look at the log file, so I just ran extraction, layout extraction, kind of a messy log file, lots of junk in there. You'll notice since I'm running since the layout is open in another magic session. This is a batch magic session, so it's running in parallel with the interactive magic. So it's complaining that it can't lock these files that are already open and locked by another process. That's fine. It doesn't affect anything. And then eventually, this is our output file. Now you'll notice, so we're confirming, I'm at the end of the file, we're confirming I didn't get that info message complaining about no subcircuit for the top cell. And if I look at the recent files, this is the file that was just written a minute ago, the output SPI file. Short and sweet, 2 transistors and a bunch of capacitors. And here's the ports on the dot subcircuit for that cell. Now, if I'm happy with that, I can do the import of that file name, and I'm specifying my target electric library name and the top cell. So this is not an opportunity. Meaning this cell name has to be a match, right? Because there can be multiple subcircuits depending on how you do the extraction. You can do a hierarchical extraction, and you'll have multiple subcircuits. So this is naming the top cell in that file. It's not an opportunity to change the subcircuit name of the top cell itself, right? They have to already be a match. So I'll run that now.
Just a quick question. You are running what do you call RCX, the spice deck from Magic. Okay. And you're saying that in a sense this is a spice deck from Magic. Okay. You need to also map it to the electric equivalent, which is the library name and the cell. So one thing, if I may point, is you said RCX import space INV4, which is inverter 4, in schematic, or in electrics. The electric cell name is INV4. It went through Magic. This is the extracted. .mag is the extracted, and .spi is the RCX extracted. I'm just not getting this .spi in Greek or uppercase.
The layout is inv4.mag.
Mm-hmm.
This is the magic file, the layout, and it will have internally. It will have references to the other. I've got a whole bunch of junk in this, but P cells. It'll have references to 2 P cells placed within it.
Okay.
when I ran extraction up here, I get the spice file. Now it's just a convention. It's for purposes of this this script, the mag to SPI script. Its convention for the default output file is to take the the cell name with the .mag and add a .spi, on the end of it. So that .spi is the netlist, the RCX netlist, and a spice SPI for spice, right?
Okay. So a quick question. Sim corners generating spice data from electric is different from magic to SPI generating spice data. I mean, essentially, since
Right.
we have
They're
yeah,
completely separate from each other. Yeah.
but from an abstract point of view, both of them should be same because one is like magic to schematic to spice deck, the other one is electric schematic to spice deck of the same circuit, right?
Yeah. Well, we hope they're the same, and we don't know that they're, until you run LVS, you don't know that they're the same.
Okay. All right. So good LBS design with no LBS errors would essentially have, if not the same, similar, what do you call it, spice decks from both these processes, right? Both these parts.
Yeah. So now, if say that LVS is not clean, or you don't know, you haven't run it. Like I haven't run it on. I didn't even run it on this cell at all. But internally, I mean, so far as the simulation will proceed in terms of a smoke test. So long as the ports are compatible, the simulation won't care whether the content, so it's up to the, looking at the simulation result at this stage, because this is not about LVS, what we're talking about right now. Our intention is to see.
Yeah. Sorry for drifting, but I just wanted to be like thorough. Yeah.
Yeah. So the internal hierarchy in this so far, there's no requirement that structurally these two circuits are a match for each other. The only thing that's critical at this so far is that the pinout is a match for each other. Otherwise, like if you had insufficient pins, or in a different order, I mean, things would be really screwed up. You may get ngSpice complaining if you have a different number of pins.
So let's say like a designer that's not ready with his design, like he's good LBS errors, like, but he's conformed to this practice of having the same port names as the electric SPI district. It shouldn't be a problem, right?
Right.
Okay.
So I was just going to review the results of this RCX import command.
Sure.
Basically, we got this, 0 errors, so that's good. This is the primary output file. So it essentially installed a modified version of the input file as this output file. And the directory structure, this is a fixed directory structure. So SPI-RCX is a fixed subdirectory under the project directory, and then the library name is the second level of the directory, and then the subcircuit name .spi is the leaf level file name. So if we look at we netlisted a test bench that places INV4, if you look at that netlist from electric, this is electric's convention of is to make the subcircuit names unique by joining the library name and the cell name with a double underscore. So that's what RCX import does. It's mimicking the electric convention. So the subcircuit name here was INV4, but if we look at this output file, you'll see that the subcircuit name is different. And it's telling us, RCX is telling us what the changes that it made. So it basically replaced this, the original subcircuit line with this subcircuit line, and you can see that the subcircuit name has been changed, and the order of the pins is different. This is to match electric's convention for how to order pins on a subcircuit when it's coming up with that pin order from the schematic. And in the particular in the challenge case, there are trim bits with brackets in them, and it's irrelevant for the purpose of this Zoom session, but you'll notice that that they're different, right? And Magic has a port. The ports in Magic have an index, so you can control the ordering in Magic, but so you could force Magic to give you natively give you the correct port order. The electric results, though, you start by sorting them alphabetically, ignoring case. So case insensitive alphabetic sort. But if you have trim bits with with bits on them like this, the bits of a bus are sorted in descending order. So counter to the it's alphabetic, ascending alphabetic, but descending bit indexes. If that's at all clear. Anyway, so it's RCX import is supposed to handle that for you, so you shouldn't have to think about it. But if you start comparing, if you look at this output, you start comparing the Magic, what port order the Magic gave you to this one, there's a reason for it. Okay, now now let's create the view switch.config file. And rerun the simulation. So our RCX switching is enabled. Our RCX Netlist is in place. Which one is that? That's the other one, I think. This is my new one, yeah. So sim. Okay, so it completes. Now I'm going to go back to the top of the file and notice that I get these RCX switch lines, 0 errors, and 1 subcircuits were switched. And it's telling me which subcircuit was replaced and it's giving me the path to that RCX netlist. So, oops, okay, I've already got that open, so let me refresh, reload that guy. Okay, so this is the schematic. So this is now the layout version of the RCX. This is the simulation using the layout results. Now, what's not managed very well yet is how do you immediately want to compare. You want to be looking at both raw files, and there's no management of that. There's no automatic management of that in place at the moment. So I've been making copies of things. Like if I copy this, well, okay, I've already got a copy of that, but copying that layout result to a -RCX raw file. And then if I remove the RCX, the view switch enabler, and rerun simulation, this time there's no RCX switching messages. I open that raw file, and I happen to have the RCX. This is the RCX version. Refresh that and plot the output. And then drag that output to the schematic version. So you can see the skew between the two circuits. This is the schematic output, and this is the green is the post layout output. So that's just confirmation that we are seeing a difference due to the replacing the schematic with the layout. Any questions?
This is great, really. So one question is, when you did the switching, right? When you switched from schematic to post-extracted spice, like spice type, back here in the command line.
What are you asking? When I did the import, or when I changed the control, the global control?
The global control.
Yeah. What about it?
Why did you have to remove this view switch config file? Is it something that I need to do as a designer? Like every time, like I make some changes and like does what do you call it? .ef config retain, what do you call it? A copy of it, which needs to be like, deleted every time you make changes in your layout, extract it, and then.
No, you can, if you want RCX extracted netlists to be used all the time, every time, as much as possible, you just leave that there forever. Leave that file in place forever. In this case, I wanted to go back to the pure schematic. I wanted to say, despite having this RCX netlist in place, basically you could remove the netlist, or you could remove the config file that enables RCX, globally enables RCX. You can choose one or the other. So I chose to just globally say no RCX switching by removing that file, that control file. Then I reran, my simulation in order to get the pure schematic results again, because I neglected to make a copy of them the first time, the raw files the first time. Okay. If I already have the raw file, so basically if I'm working on the schematic, I may, if I edit the schematic and I netlist and this, and I have an RCX view and I have this control enabled, then if I edit the schematic,
it's going to overwrite your raw files.
Yeah, but I may see no change. I run the simulation. I look at the waveforms. I see no change. It's like, what's going on? Because I'm expecting that my schematic change will have an effect on the waveforms, and it won't, so long as it's still swapping in place the layout-based netlist. So, there are times you want to go back to just pure. So we need more controls to make this much easier to switch back and forth and turn things on and off. So we know that, and we have a plan for that, but it has nothing super flexible has been implemented yet.
Yeah, like I said, in the world of programming, the hacks, this is a sophisticated hack to get your circuit. As a circuit designer, yeah, this is fine. I mean,
well,
as long as these designers are like instructed well that, hey, you are circuit designers, I understand. But this is something you would
this
have to do.
this is a somewhat manual process by which to get it done. Yes.
Yep. But I mean, it does a job, right? So that's what I'm happy about. Post layout simulation and everything. That's like, wow, amazing. So another quick question is, at this stage, if I have a given cell, a top cell, and I have like multiple like subcells within that top cell, like XBG, I've got op-amp, I've got my startup circuit, my PTAR circuit. When I have all three of these guys under the umbrella of a big, huge top cell, okay, how do I, what do you call it, how do I do this sub-cell level switching? Is that something which is ready, or we are not offering to these challenging at this stage? I mean, we are not offering this feature to designers.
Right. There's no useful, nice, flexible controls for that. But by managing which of these files are present or absent, obviously if there's no RCX netlist available in the directory structure, this type of directory structure, there's nothing to be switched in place of that. Now, when you talk about hierarchy, you immediately need, say you have test bench 1, and inside that you place your real device under test 1, and inside of that you have subcell 1 and subcell 2. So you have a hierarchical structure where these are placed side by, in the layout sense, these two will be placed side by side, forming up to create the layout of DUT1. Now, so I could do layout extraction individually on these guys, and run a simulation such that the test bench is a schematic, and the DUT1 is a schematic, and these two are getting it from an RCX view. But as soon as I generate an RCX view at this level, if I complete the layout for the whole thing and generate an RCX netlist for DUT1, then these older the individual RCX netlists for these guys in the directory structure will no longer be used.
Okay.
Should no longer be used. Now, there are a number of cases like that where we need more work, we need more testing about whether or not it works. But put simply, especially if you say with this, to simplify matters, if we do an extraction of this flat, it won't, on the layout side, it won't have any sub-hierarchy. And then when this is switched in to the schematic, in place of the schematic version, there's no question that it'll the RCX version of that includes all the circuitry that came from what which in layout were subcells, but in the netlist it's all it's all locally flat. So all the layout stuff is added. If somebody really wants to see what's going on, one can look at the electric netlist, as after the switching has occurred, and observe how the switching is accomplished in the netlist. All these RCX guys get included at the end of that netlist. So the native, whatever electric netlists will be earlier in the file, and all these included RCX netlists will be included after them. So they have the last chance to redefine. They essentially redefine subcircuits if there's a subcircuit match between those RCX names and native whatever electric subcircuits electric created. The RCX will redefine the electric created subcircuit and take over, quote unquote, take its place. That's not to say that all the hierarchy issues have been worked out or tested well, or so that's also a work in progress.
And another question, in your opinion, if I'm supposed to get this RCX extracted view, get it into electrics, create a test bench around it as a designer. Okay. Now the fact that I have like minimum C and minimum R in this RCX extraction. The RCX extraction tool has this, what's the minimum threshold for R and C for which you would have these series resistances and capacitances, like modeled based on the layout view. Okay. Now, if I have so many RMCs, like it means that I've got more, passives, like more abstracted passives added to my existing spice tag. So, and when I have an RCX extracted spice tag with all these added passives, do you think ngSpice in its current state can handle such a dynamic and a diverse matrix of instances to begin with? Like if I'm supposed to run DC analysis of AC analysis. Do you think it's a good idea?
Well, it's highly speculative, but I mean, we won't know until we try. But basically, I don't think there's a massive, you know, passive RC networks. I don't think there's a massive issue with them in terms of ngSpice AC analysis.
Okay.
Knock on wood. Famous last words. So it remains to be seen. I'm not that much experienced lately with our latest Magic tech files with resistance extraction. Magic has essentially two levels of like interconnect resistance extraction methodologies. One that's kind of simplified or basic, and then one that's kind of more considered to be more thorough and more precise. As far as I know, our tech rules, the tech rules that we're making available, the tech file that we're making available to the users to directly use, does not use that second, more sophisticated version of resistance extraction, and I haven't tested it. Even the you know, the simplified version of resistance extraction, I haven't seen it. This Magic Magic to SPI script that was not what I was expecting. Okay, unknown option dash help. Okay, so that by giving it dash H, I got it to spit out a usage information, and there's these thresholds. There's resistance and extraction thresholds that you can pass in. So if there is a capacity issue in simulation, one can possibly, you know, prune out some of the smaller capacitances, some of the smaller parasitics. Okay.
Okay. Yep. That
So
answers most of my questions.
how are you doing on layout? Do you have layouts with ports that you're ready to run?
No, I've got a multi-hierarchy subcell-based sample layout. I mean, sample schematic. I'm yet to like extract a layout out of it and like, you know, create a magic layout out of it and try to map the ports from the schematic to the layout. So it would take me a while. But to begin with, I want to start with where you left off, the inverter testing. At least if I have a layout of inverter ready, you know, maybe I can just practice this process of extracting, and I can later worry about, like, you know, trying it on my version of schematic. Because Tim and I, we had this test schematic, which has got two levels of hierarchy, and it's a simple differential pair. So I would later test it on that, maybe once I have other things like, you know, taken down. But to begin with, I'll just start with your inverter testing example.
Okay.
And I'm still working on some of these other simulations. So would you be at the office today afternoon, today evening?
Sure.
All right. Okay. So there's two questions. Number one, where can I get this inverter schematic and inverter layout? Would you be pushing it to Volt, to the eFabless Volt, or
Well, where do you want it? Do you want it on your dev account
yeah, that would be great. Or dev account here. Okay, I can
or
work on
Andro
that.
7 or Andro 7?
No, I would rather prefer to work on dev with the most recent changes.
Okay. Yeah, I'll put it there.
All right. And another question is that when it comes to production, the production environment for designers, the PDK part name. Okay. So is that PDK part consistent with Android 7 PDK part, or there are changes?
Yeah, the PDK path is the same on all machines. These Andro machines use symbolic links in the structure of the flow installation. So certain tools somewhere in the Open Galaxy in the project manager, it does a real path on the PDK directory, so it essentially resolves the symbolic link, and you end up seeing /dev something or other in front of it. But that should not cause any issue anywhere. But if you're comparing, you might see that from time to time in certain log files or something, but it doesn't cause any problems anywhere. I don't know why you're asking about that. If you saw the /dev, it was puzzling to you or something.
Oh no, this is relating to what Norman needs from me for those standalone what do you call it? Spice text, self-contained analysis so that designers can check for what condition is the design failed. Like, so this is completely out of the discussion that we are having right now. It's not related to RCX. It's related more to spice text, because we said that we need to tell designers, we need to communicate with designers and tell them that the designers still not right. Like, it still doesn't work or even start up under certain conditions. So essentially, he wanted to push a self-contained folder with spice text, all the waveforms, and a small side note saying that this is where this thing is getting failed. Kindly go and fix it. And push it into their production accounts. That's what the initial plan was. So,
well, we're getting off topic. We can stop the recording of this.
Yeah.